Oh, got it. Cheers. Yeah, in the end, I guess I could quickly go over that again. So yeah, for now, so current folder has all your codes in it, which is kind of really nice. And then you have this place called workspace. Workspace stores every single variable you have. It is by far the most useful thing that MATLAB has. No other coding language that I've seen so far, or IDE, has this feature. This way you can immediately tell basically all the variables you have and what's inside them. It even tells you their size, their value, so you can double click on it. And it kind of like shows you, hey, these are the values stored in this. So you don't have to individually go through your code and see what's up. It's perfect for debugging. And that's basically much it. Yeah, opening a file, all that stuff. I'll go in more detail on what cool stuff we have. I don't know if you can see this tiny thing. It says MATLAB Drive. So MATLAB Drive, with your McGill account, you can create a free MATLAB Drive. It's kind of like Google Drive, but you store all your codes online basically. And you can run it from anywhere. You can run it from school from here. So I highly suggest you all set that up, look into it later. Because MATLAB has a phone version, you can download on your phone, and you can run your codes on your phone too, which is kind of nice. I don't know if you ever need to show off to a prof or something, I don't know. So yeah, that's basically everything about the MATLAB environment. I'll move on to kind of like the basics of variables. So here, I'll start off. So now, what I did there was in MATLAB, basically some keys are special keys, right? So I think it's called percentage or module key is a comment key. So you can write anything here and it will be counted as a comment. So it will not run it, right? So it'll just go past it. And the other special thing is if you put two of them with a space, it turns it into like a chapter. You can see how this is light green, that's bold green. Chapters are useful because you can type like a bunch of stuff. And let's say your code is very long, you can just click on this and it collapses everything. So it's a very neat way for you to be able to like make your code shorter if you want to look at other stuff. Because sometimes you have like hundreds and hundreds of lines and you don't want to scroll past everything. You can click it and then boom, you're done. So highly suggest this chapter thing. But yeah, enough about that. Going over a bunch of basic coding stuff. Does anyone here know any other coding language? I'll open the chat too. Just curious because I can compare with other code languages. You can type in the chat or whatever you like. Or is MATLAB the only thing you somewhat have heard? Because maybe I think they've taught Python at 208. But yeah, if you know Python, yeah, basis of Python, yeah. If you know Python, they're somewhat similar in that they're kind of advanced languages. So any other language, so most of the languages, C++, Java, all of these, you have to define what the variable is. So you usually say like int x equals like 3, for example. Basically means x is an integer of 3. But MATLAB is a super duper small language, so you don't even need to do that. You just run off the bat, type x equals 3. Right. Now, for those of you who know Python, right, you know that you don't put this little semicolon thing anywhere. So what happens in MATLAB if you don't do it? So I'm going to run it. You don't get an error, but you notice that it prints x equals to 3 on the left side. Basically means if you don't put a semicolon at the end, it prints that into the command line. So just so you know what it is. So it's kind of useful for debugging and whatnot. So just to demonstrate again, so x equals to 3 and y equals to 2 or 1, let's say. But now I put a semicolon. So if I run it again, x equals to 3, but it doesn't print the y, as you can see. Now the command window is kind of cool because you can kind of like run actually one line commands here. So you can just say, z equals 2 times x. So everything that's been here, it's already stored in your command. So you can run this and you get a value for this. So you don't actually have to write it here. However, z doesn't exist here. So if you go to your workspace, you can see all the variables I currently have. So x, y, z. So I think that's kind of cool. And it already says the value too, z equals to 6, x 3, and y is 1. Don't worry about the size so much. That's the size in memory. So that's so far so good. So far, I think hopefully everything should be good. One of the advantages of using semicolon is you can kind of like write multiple things on the same line. So if you can see, if I can try to write x v equals 2 here, I would get like I'd get an error saying, oh, missing a semicolon. So you can't actually do that. And you can see on it, it says you can't do that. But here I can write z equals 4. And that's totally fine and acceptable. And you can see now the value of z has been updated there. One important thing, MATLAB, like many other modern programming languages, is not space sensitive. So you can write z, you don't have to write a space here, or you can write w all the way equals, I don't know, 12. And all of these will work. So basically it doesn't count these. Now you might ask why you want to do this. I'll explain later. Just for like formatting your code and make it more visible. So far, so good, I think, hopefully everyone. And the other two main types of things you'd notice are strings and characters. So A equals to hi, that's a string. And B equals to like a character C. So it's double mark, it's a string. 1 is for a single character. And if I print them, you can see all the way here. It might be very tiny. It says string, 1 by 1 string, 1 by 1 character, and these are all doubles and integers. And the values right there too. So cool. Now, so far you've seen every time I run the code, right? I get basically the same thing here on and on and on. Now that's quite confusing and clutters your things all the time, because look at this. Let's say you run this code once and look at my workspace. I have all these variables, right? And let's say, oh, you realize, oh, you were wrong. You actually don't need A and N in your code, right? So you run it again, but they're still here. And they can realize how that would be very messy, right? Because let's say you use A later on in your code, but you actually didn't assign a value. So now you have an absolutely random value for A, right? So that's why probably one of the most important things that you have to remember from this workshop is put these magic words on top of every single code you write. And the things are CLC, clear, and close. Close all. I'll explain individually what they mean. So CLC basically means clear a command window. So if I type CLC here, it clears everything here. So now I have a fresh command window to work with. I don't have all that stuff to look at every single time. What clear does is it clears your workspace. I highly suggest you clear your workspace every time you run your code again. That's because you know the variables you're going to have in the workspace are the variables you have in your code, and not just there from other time. So if I write clear, all of these go away. And close is super useful, is because let's say later on, I'll show you how to plot stuff. And every time you plot something, MATLAB opens a different window. And you have to, if you have like 12 plots, you have to close them one by one. Whereas if you just type close, MATLAB will close all files, right? So that's quite nice. You don't have to, I remember one of my assignments, I plotted 23 things and I didn't know close was a thing. So every time I tested my code, I had to like click the X 23 times. So close all saves you a lot of time. Just remember these. So every single MATLAB code you write, these three are on top all the time. Highly suggest. Okay, perfect. And kind of like other good code etiquette practices is start all your codes with the purpose of the code. So here I'm talking about variables, and then write like comments or how to use it. You might think, oh, I'll always remember, but sometimes you're gonna write so much code that when you look back, like I have no idea what this does. It's kind of nice that if you top of your code just says what this function actually does, right? So highly suggest basically start your code always like this. Yeah, any questions so far? Otherwise, I'll move on to fun matrices stuff. And you don't have to follow along. This is hopefully right now. I see recorded, so you can kind of play back and see at your own pace. All right. Since nothing's there, I'll continue to lovely matrices. So okay. So MATLAB is kind of extremely nice in the sense that your matrices and vectors are not a fixed size. In other programming languages, if you create a 2x2 matrix, you can't turn that into a 3x3 without creating another matrix. Whereas MATLAB, it's called dynamic. So that's quite nice. And one other huge thing is in arrays, slash vectors slash matrices. First index is 1, not 0. Again, all top popular coding languages start from 0, whereas MATLAB starts from 1. Intuitively, math, it makes more sense, but I don't know. Computer science people are very, this is a very popular meme, how MATLAB is the only one that starts with 1. So now what that means, what does that mean? I'll do basically a practice. So now I'm going to practice everything about how to create a matrix, right? So concept matrix creation. Let's say I want to make the following vector. So 0.1, 0.2, 0.3, all the way to 10, right? Now, one way to do this is literally typing it out, right? So R1, the name doesn't matter. I'm just going to keep the names the way I like. You open the matrix bracket, and then you basically type it in. So 0.1, 0.2, 0.3, 0.4, 0. Oh, not to 10, not all the way to 1. Yeah. So all the way to 1. Now, if I run my code, don't forget CLC close. I get it printed here because I didn't put a semicolon. It just says columns 1 to 10, all these values. Now, is there another way to print or to store a matrix? Yep. So you can also do R2, the exact same thing, but if you put commas, so comma 1, comma 2. All that. Now this is preferred because it's more clear when something ends and when something begins. So I'd highly suggest always put a comma. And if I run it, you see both are exactly the same. Now, kind of a question for y'all, maybe the name will give it away. What happens if instead of a comma, I put a semicolon? I'm trying to see if anyone's familiar with MATLAB here. So what happens if I run this? Any guesses? Maybe I'll pick on someone here. Emma, do you know what happens? Yep, it's a column. So I'll run it and you see what difference is. So as you can see, this was a row vector. So everything was in a column. This is a column vector. So these are all different rows. So kind of be mindful of what you're using. Okay. I'm just gonna suppress these. So now I really don't, there has to be a faster way than to kind of write this every single time, right? If something has a pattern, we should be able to find a better way to do it. So there comes the whole concept of like the start, increment, and end. So this is pretty cool and blows my mind that not that many people know that this exists, and they do like for loops and all that stuff. But literally what you can do is your start point is 0.1, right? Your increment, which as you can see, every time is 0.1 from 0.2 to 3. So your increment is 0.1 and your last point, which is 1. Right, so now if I run this, as you can see, I get the same result. I can see how this is much quicker to write than that and much easier to read too. So that way I know everything has a pattern. Whereas like if this was a random point, if I look at these, I'll assume it has a pattern, but then this wasn't the pattern, right? So quite useful. Now, a little, that's just to demonstrate matrix addition and multiplication. But what you can also do is R4, you can start from 1, increments of 1, and go all the way to 10. And divide everything by 10. Now, in MATLAB, the way dividing by scalar works is it divides every single entry here by 10. So if let's say if I don't have this right now, it's all numbers from 1 to 10. Now, if I divide it by 10, It just divides everything by 10. So that's quite nice. Now, one other thing that in matrices we often require are transpose of a matrix. So if you don't know, transpose of a matrix is when you like flip the row and column with each other. So what you can do is, as you saw, I'll put these out here again. So the row and column. So row is all that, column is that. So technically R1 and C1 are transpose of each other. And just to demonstrate that, I'm going to say C2 is equal to transpose. To transpose a matrix, you can just use the function transpose R1. And you can see C2 just becomes C1. Now, since the creators of MATLAB realized transpose is such a common thing, and it's quite long to type out transpose, like the amount of times I've had a misspelling there, insane. So they were great, generous, and they made this little shortcut of one little thingy. So that does the exact same thing as a transpose. As you can see, C3 is not the exact same thing. So this is quite useful to remember. So transpose. Any questions so far? Because the next topic I'm going to cover are how additions, multiplication, and divisions work. Okay, then I'll carry on. So in MATLAB, how does adding two matrices work? Thankfully, it's quite easy because it's a math-specific language. So if I were to add R3 and R4, R3 is exactly the same as R4, right? They're the exact same. So we would expect the result to be basically the addition of both, and that's exactly what happens. It adds the first, let me print out them individually. So R3 and R4. Okay. So it adds the first element of each of them together. So R3 and R4 adds them to become that. So that's quite straightforward. Now, what happens if I try to take their product? So product R3 times R4. Any guesses? What would happen? Wait a few seconds. Okay. Well, the dimensions of R3, right, are 1 by 10. So this is a 1 by 10 getting multiplied by a 1 by 10. Now, if you remember lineage at all, to multiply two matrices, these two numbers have to match. So the column of this one have to be the same number as the rows of the other one. And so they're not the same here. I get this error. It says the good thing about MATLAB is their errors are quite helpful. So it immediately tells you incorrect dimensions of matrix multiplication, right? So maybe, so I'm going to comment it out so I don't get an error. So now see what happens if I try to do this. So R3 again, dot multiply R4. So I added an extra dot here. And what that does is, so now the product, it multiplies individually the cells by each other. So it multiplies the first cell, results would be here. Multiplies the second cell. So this and this, results would be this. This is such a powerful tool. So dot multiply, it multiplies two cells individually. The amount of times I've seen people trying to loop through two matrices and multiply them together, insane. Whereas you can just do it in one line, and it's much more efficient. So highly suggest to know this trick. And so similarly, you can also divide, right? So R3 dots divide by R4. And since R3 and R4 are the exact same, I expect to get all ones, right? So these are all ones. Amazing stuff. I'll carry on. So yeah, so far you saw if I wanted to get like a pattern of, increments from 0, 1, 0, 2, 0, 3, how I would do it. It's that way. Very, very super useful. So highly important. But now sometimes, especially in, a lot of times in math and a lot of times in stats, I guess they're the same. You would like to do like specifically n number of data points in a region. So let's say you want to have like 30 samples between 2 and 3, right? You could do the math and figure yourself out and then put the increment here. But in MATLAB, you have this very, very cool function called linspace, which stands for linearly spaced. Don't put an E here. The amount of times I've put E here, for some reason, you'd think there has been E, but no, it's just lin spaced. And so what you do is your start point. So I'm going to say 0. Your endpoint. So 100. Oh, sorry. Let's say 34 is my endpoint. And the number of samples you want to have. So as you can see, it even gives you a help here. So x1, x2, and number of points. So 100. I'll comment it out here just so you can see what is what. So I have 0, 34, and 100 here. So what this does is it creates basically a matrix with 100 data points between these two variables. So if I plug it, you can see that's the result. Well, I don't exactly need it, but hey. So that's quite nice. So yeah, these two you're going to be using them quite a bit in creating much of stuff. Now, the two last things about matrices that I wanted to cover. The first one is, well, really important, inverse of a matrix. There's going to be a lot of times where you have to solve a linear system of equations. And a linear system of equations is just ax equals to b, right? So you have a bunch of coefficients a, you don't know x, and you have your results b, and you want to try to find b, right? And so how do we normally do this? Well, we normally just say, take the inverse of a, multiplied by b, so x equals a inverse a. So basically x equals a inverse of a times b, and that's how you get x, right? So if I try to demonstrate that, let's say I have a matrix A, 1, 0. And so here I'm going to show you why is it important that MATLAB doesn't care about empty spaces. I tab and I do 0, 2. Right? This creates a matrix. If I let it play, this creates a matrix like this. Right? To me as a reader, it's much more clear that this is a matrix than doing this. Right? They're the exact same result, as you can see. However, it's much nicer if you lay out your matrices like this. So that's why I highly recommend like these tiny little formatting things can make a huge difference in how you debug your code. So highly, highly suggest align your matrices like this. So that's your matrix A. And for B, your results are, let's say, 1 and 4. Right? So the first way you can do that is say x1 is equal to inverse. So inverse is a built-in function of the inverse of A times B, right? And that's exactly the formula we have here. X equals inverse of A times B. Now, you can immediately see, even though the code runs, if I run the code, it solves for X. It's giving me a tiny little error here. I don't know if it's possible, you can see. But it says, yes, this is correct. What you have, the math you have is correct. However, taking an inverse of a matrix is super slow, right? You learn in your numerical course, one of the most expensive things to do computation is inverse of a matrix. So MATLAB actually even recommends you, hey, do you know about our faster way of solving for X? And that is A\B. And this does exactly the same thing. You can see x2 is exactly the same as MATLAB, as x1. So the backslash operator solves for x2. Again, this is one of the most key things that I highly suggest that you basically remember out of this. I'll mark these like this just so you know later on. What are the important things? So these, super duper useful. So yeah, any questions on these? And I think in your numerical courses, maybe you sometimes learn about different ways of solving for ax equals b. But yeah, that'll be a math thing. No, not for right now. I will move on to the last thing I want to talk about matrices, and that is the special inbuilt matrix functions. So sometimes you want like a matrix of zeros or a matrix of ones, or like in the identity matrix. Thankfully, MATLAB has all these inbuilt. So let's say if you want a matrix of zeros, right? You can use the function zeros and you give it the dimension you like, so 2 by 3, let's say. And if you run this, you can just see I get 2 rows and 3 columns. So 2 rows and 3 columns. If you don't give it the second one, so if you just say zeros of 2, it's going to give you a 2 by 2. So if you don't give a second one, so if you give like 5, it's going to give, oh, not 25, 5. It's going to give you a 5 by 5. So heads up for that. Make sure you don't make that mistake. Now you can also do the same thing, but for matrix of ones. And that's also sometimes very useful. The reason why these are useful is in coding, it's always nice to pre-allocate the memory for what you're trying to do. So let's say you know you're going to have a matrix that's, I don't know, 500 by 500. Rather than adding stuff to it every single time, create a 500 by 500 of zeros and update it, right? Because that way you're telling the computer, hey, I'm going to need like 500 by 500 data points. Can you put it aside initially? They can do that much quicker in your code than, oh, every time like, oh, can you add another one? Can you add another one? So pre-allocate memory. That'll be like an advanced topic, so don't worry about it too much right now. And lastly, something that you might use quite a bit in lineage stuff, if you want to have to do, is the identity matrix. So, and that is with the function I. So I of n creates an n by n identity. So I of 5, I of 5 makes a 5 by 5. So the diagonal is just ones. So that's quite useful. I've also seen people try to do this manually themselves, whereas this is already a built-in function. So super duper useful. And yeah, those are all the matrix stuff. Any questions here? There's quite a bit more, but so far I'm just gonna go into these slowly, because you can have like a matrix of matrices. You can find something in a matrix. Just know all these exist. The best tool you have, Google it. Like literally, the good thing about MATLAB is the support for online is quite nice. Their documentation is insanely good. So whatever question you have, just Google it. There's probably an answer. So don't try to build everything yourself. I'll move on to loops. Kind of loops are, when computers have an advantage over us, they can just do something 1,000 times. So they're quite useful. Now, the two main loops in every single programming language ever built are for loops and while loops. Hopefully, has anyone not heard of for or while loops? Just so I know how in depth I should go. I'll just put it here. It's a for loop. I'm going to assume everyone's heard of it. So for loop, I'll go ahead with an example. Oh, yep, both are talking to it. Amazing. So the first example, the only example I have for loop is calculating factorial, right? So n factorial, I don't know even how to spell factorial. Hopefully that's correct. It's basically just n multiplied by itself that many times, right? In MATLAB, the quick way is x equals 2 factorial. That's a factorial sign. But yeah, you don't need to. I'll do it with a for loop. Yeah, thank you for correcting my spelling. I don't know how to spell. Okay. Okay. So the way you do it for loops is, well, let's say for this example, I'll say n equals to 6. And well, for comments, 6 factorial is equal to 720. That's just for us to know. The way we can do it is like this. So factorial of 1, start at 1, and then we loop through every single value of n, right? The way we loop in MATLAB is for and end. There's no need for like any other programming language like these stuff or anything else. It's just for and end. And in your for loop, you say the thing that has to be incremented. So I say I equals 1 to n. It's quite intuitive to read. Like you don't need parentheses, you don't need anything else. That's pretty much it. That's your for loop. Basically says I starts from 1 and goes up 1 by 1 all the way to n. This is a short way of saying this. Now this basically, if you look at it, looks very much like the matrix thing I showed here. That is actually a tiny for loop, which is kind of cool. So increment I from 1 to n. And the way we can basically do factorial is just multiply by itself. N factorial is equal to n factorial 1 times I. Now, if I run the code, since I don't have a semicolon, it's going to run it multiple times to see what happens. Starts from 1, multiply by 2, by 3, by 4. So it calculates everything up to 6 factorial. Right? So now I'm going to have a trick question, and I'll wait till someone attempts to answer. Is this valid? So I'm switching around 2 is equal to 1. So I'm switching around the order. So here I start from 1 to n. Now I'm trying to go for n to 1, right? They should both be the same, right? No matter if I start from the beginning or the end, it should be the same. But would this code run? I'll wait till someone mentions it in the chat for like 2 minutes. Right, that should be enough time. I'll go ahead. So I'll run it. We'll see what happens. I won't print this. As you can see, nothing happens. I don't get an error. So that's why it's such a lethal thing to do. So you can even see it's not even running. Right? Nothing, it's not giving me an error. That's because it's not a code error, it's a logical error. What that means is the way this is working is it's trying to increment it up by 1. So n is already greater than 1. So this never runs, right? To be able to loop backwards, you have to write the backward thing. So you have to say, hey, go down by -1. So now what this does is it starts at n and it goes down by -1 every time until it reaches 1. So now if I run this, I do get a result. So this is such an incredibly common mistake that I've made. And the reason it's such a terrible mistake is because it doesn't warn you about it, right? So you can get different results and you don't even know about it. So highly, highly be cautious of this. You can't go backwards without having -1. Yeah, so if I now just have both running, you can see the n factor 1 and n factor 2. If I go to my workspace, the values are both 720. Cool. And now while loops. So it's going to be the same example I'll try to do for while loops. Now the way while loops work is it checks the condition to see if it's true. And if it's true, it just keeps on going. So I'm going to go with the same setup I've been having, but I'm going to call it 3. And I is equal to n. Now I'm telling it while I, in MATLAB, in every other programming language, it's exclamation point equal means not equal, but in MATLAB, as you can see, it even tells you it's this little thing, and you can actually press and it fixes it automatically for you. So that's quite nice. So this means not equal, whereas double equal means equal. So I'll get to those in a bit. So while I is not equal to 1, exactly the same formula I've been using. However, since in a while loop, it only checks the condition, it doesn't do the -1 by itself. You have to have it in the while loop. So I equals I minus 1. So now note MATLAB doesn't support I minus I plus plus like every other programming language. Every other programming language, if you write I minus minus, it's the same as this. But MATLAB doesn't have that, so keep that in your mind. So now if I run this code, you can see n factory is also set by. So while loops, not as often used as for loops because for loops are more compact, but they have very specific cases, which I hopefully I'll show you in a bit. But yeah, that was everything about loops. You will use these quite a bit to loop through stuff as well. It's quite useful. Any questions? Are for loops or while loops faster? Oh, that's a good question. So if you want to talk about pure speed, if I'm not wrong, while loops are faster than for loops, right? Because there's only one condition that it checks, whereas for loop it checks and also increments here. So while loops are a bit faster, but I don't think it's that by that much of a margin. So don't worry about it too much. Yeah, that's a good question. You know, initially when you write code, you're not really worried about, oh, the amount of memory I'm occupying, or oh, the amount, like how fast my code runs. Just first start with, you know, does it run correctly, and then worry about, oh, how can I make this faster? Kind of like that's what separates like a good code from like an insanely good code. I will move on to what's next. I have 5. Oh, I didn't create this. Oh no, I have it here. Okay. Yeah. So if statements. If slash switch. So, you know, sometimes you're doing something and you want to check, you know, if the value is correct. Let's say you get an input from a user, you want to check if it's a specific thing, or let's say you want to check if your value is positive or negative. You have to use like if or if else statements or switch cases. Now, switch cases are maybe something you have never seen. It's very popular in MATLAB, but if statements are everywhere. So I'll do a bunch of examples with these. So I'll first start with if, else if, else. So here's a simple, basically example of determining which number is bigger, right? So I have an A that's 6, a B that's 9. I want to see which one of these two values are bigger. Right. So the way you can do this is just say if A is bigger than B, you do something here. So slash n. Now I'll end it here. To be able to print something to here, right? You can use the command fprintf, and that basically just whatever I put here, it just types it into here. It's quite nice just so you can, print stuff to the user and all that stuff. It's quite nice. And the \n, that just means print a new line. That's just the code for print a new line. And you put it inside. So always put everything here. So if I put some random thing here, that's going to give me an error. Be like, hey, that shouldn't be there. So I'm going to run this code. Nothing should happen because A is smaller, right? So now let's do the other case. So else if B is greater than A, B is bigger. And just for the sake of it, I want to have a last case. I'm just going to type else. Now, what would the last case be? If A is not bigger than B and B is not bigger than A, that means they're equal. And end. Right. And I highly suggest following the indentation thing. So have all the if else's here and then this be indented by 1. So now if I run, it just says B is bigger because B is bigger. So that's quite nice. And I'll go to tips and tricks. Maybe I'll do it now. So here's like a cool tip. You see how I've been doing these comments? Let's say you're doing this as a test and you want to, so I'll array it here. So you're doing these and then you want to like kind of comment all these. What you can do is individually go type this thingy there to comment them, but it takes a while. Or if you select all the text you want and press Control, or if you're on Mac, Command, so Command R just comments everything. So to comment a bunch of stuff, Command R. To uncomment, it's Control T, or Command T. If you want to shift things to the right or left, like this, so you don't want to like tab it every single time yourself, or shift back, which is very useful again. Here are the codes for those two. There you go. These just make your life quite much easier. I found, at least, having it properly intended code is quite nice. So kind of have these in the back of your mind that you can do these stuff. Especially the comment thing, I think, is the most useful part. I learned about it, unfortunately, much later than I should have. So you've probably always seen if-else stuff. Something you might not have seen are called concept switch cases. So switch cases, the way you can use them is to compare if something is equal to something else. So you can't say, I'll write it out here. So let's say I want to check if my number is equal to a specific thing. I don't have a special task. So let's say my number is randomly chosen number. Right? You write switch your number, and then you define your cases. So I have, let's say I have one case. If the number is equal to, I don't know, like that, then do something special. So printf, that's a high number. Right? Now you have another case if your number is equal to, the same number there. Then I just wanted to print nice. Now you can also have multiple conditions in one thing. So that's what just makes it super nice and super compact. You can just say, oh, if it's either equal to this or equal to that, do something else. So do something here. And similar to how if has an else statement, this has an otherwise. So if it's equal to none of these, just print nothing special. Now, obviously, you can have different things here, but I just put these. Now, the reason this is much better than an if-else thing is because it's much more compact. You can then immediately see, and you don't have to type out number. Because in if statements, you have to type out if number is equal to that, number is equal to that, number equal to that. But here you can just type this every time. So if I just run this, I get nice because I match this case. Now, what's important about this compared to other languages is you can see 69 is also in this case. However, as soon as I hit this case and I match the criteria, it ends. It does not check for the rest of the here. As soon as this is done, it jumps to the end. So be mindful of that, because in other languages, that's not the case. For example, in C++, if you use switch, if this case is true, it also goes to the second case. Just check if that's true too. So keep that in mind. Yeah, that's kind of it. Yeah, the one thing I was talking to you about is this has to be a value. It can't be if, I don't know, case number is less than 10. So that wouldn't work. If I run this, that would not work. It would say you can't have a logical error here. So keep that in mind. And that would be it for here. Any questions? Because actually, no, I had one more example here. But it's going back to loops now. I wanted to show if statements first before I come to here. So what happens if you want to break out of a loop early, right? So what does that mean? You know, I'm doing a bunch of stuff in my while loop, but then as soon as I realize, oh, I don't need to continue anymore, how do I stop, right? That's quite important. So the example I'm going to show is example, find index of the first even number in a vector. Right, so what does that mean? So if I have a vector like this, I want to find the first even number in this. So the first even number is 12, right? So how would I go about doing this, right? Well, the main idea is to go through each and every single one of these elements, see if it's an even number, and then stop. Oh, wait, there's a 4. Oh, wait, that's a 5, sorry. That's a great point. That's a great point. You caught me there. It could be a 4. I guess I could just change that. Yeah, I'll have it be a 4. Yeah, I mistyped. It was supposed to be 5. Yeah, let it be 4. We'll see. So let's start coding a bunch of stuff. And in this chunk of code that I'm going to write, just 3 new concepts. So I wanted to kind of like pile everything up to one thing that makes actual sense. So for I equals 1, 2. So I'm saying start from the first index all the way to. Now, here's a hugely, hugely, hugely important tip. As much as you can, avoid using constants. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I could pretty much write from 1 to 8, right? But let's say I want to run this code for a different question, and this doesn't have 8 variables. This will no longer work. It will absolutely screw you up. So the best way to do it is just say size of your vector and the number of its dimension, right? So what size does is it looks at vector. Let me run this code just so you can see. So right now, if you can see, vector is a 1 by 8, right? If you can see here, it says it's a 1 by 8. What size does is it looks at that 1 by 8. I'm telling it, look at the size of vector this and choose the second variable. The second one is an 8, right? Because I want the number of columns. So now this is a fully functioning code for any size the vector is, right? So it can be 100. I no longer have to change my code. Super duper useful to write everything depending on the sizes. So yeah, that's just one major point. Now, what I'm interested is if the number is even, right? So MATLAB, every other coding language, if you want to check for remainder, so if you want to say like remainder of 5, so 5 remainder 2, that would give you the remainder of a variable, right? But in MATLAB, the percentage, as you've seen, is reserved for comments. So that doesn't work. So what they've done is they've created their own modulus, I think it's called, function. So mod your vector, so vector and 2. So I want the remainder to 2, right? And I want to see if it's equal to 0. That's what it means for a number to be even, right? Couple of things to note. The double equal. If you use single equal, that does not make any sense because it even gives you an error. Because it interprets as if you're trying to put 0 into here. Use double equal, something that will mess you up the first few times. Double equal checks for equality. Another thing, what I've written here is wrong, right? Because I'm checking for vector, whereas I want a specific element of that vector. So the way you access elements is not like this. That's every other coding language. In MATLAB, it's simple parentheses. So vector, and I want the element I. Right? So I'm looping through every single element. So I want that element, module 2 equal to 0, 0, 0. And I wanted to print, oh, I found it. So the way I do it is, and this is a very powerful tool. So printf. So the first even number in vector is at, I want to print the index first, is at index. Now MATLAB, if you want to print like a variable inside, your pre-written, words, you can use the %d for integers. I highly suggest you go MATLAB printf. It has a manual for what to use for what. So it's quite easy to check. I can show you where to check too, actually. That'd be nice. So MATLAB printf. Like, literally, no one can do MATLAB without Google. So here's basically if I look up MATLAB fprintf, it's quite nicely laid out. You can scroll all the way down and it tells you all the different options you can choose. So I highly suggest whenever you want to do something, just Google it. You don't have to memorize anything, basically. So I'm using the D here, which is for integers, right? So I want to print the index there and the value. The value is also done. And I print my index. So my index is I, and my value is now here's another trick. As you can see, what I have here is a super long line of code, right? It's not exactly nice for someone who's trying to read my code to actually see this and have to go down here and scroll to the right, right? So the way you can combat this is break down your code into multiple lines. Kind of the same thing I was talking about in matrices here with, break your matrix into 2 lines, just so it's more visible. Here I can do the same. Where am I? Okay, here. The way you do it for inside something is you put a bracket around it. And wherever you like to break it, let's say I want to break it here. Let's say I want to break it there. Yeah. You end the string, go to the next line, start your string. And to be able to tell the compiler, like MATLAB, that, this is a continuation of this, all you do is type triple dots. Basically, it tells it that, the thing you see on the next line is a continuation of the first line. Super duper useful trick. So have it in mind. So now this way, whoever tries to read my code can just see everything in one line, right in under the thing. So it helps prevent long lines of code. And end. So whatever if or for you have to end it. So now what happens if I run this code, right? Again, I have this \n to print a new line. Now, as you can see, if I run it, yeah, it indeed finds 4. That's one good thing. But however, it prints all of them, right? Whereas I just want the first one. So it finds 4, it finds 12, and it finds 24. But I only want the first one. So how would I stop it from printing the rest? Does anyone have any ideas? How do I stop it as soon as it found this? Break, exactly, yeah. So as soon as it meets this requirement, I type the keyword break. Now what break does is immediately if it reaches break, it jumps out of the loop you have, right? So if I run this now, boom, only prints the first one. So as soon as it meets this first requirement, it breaks and jumps it. Now, if you had a for loop inside another for loop, that wouldn't stop it. Just to demonstrate what I mean is if I run this code 3 times, it will still print it 3 times. So break only jumps out of the first one. It does not jump out of the full thing. Keep that in mind. Sometimes I genuinely thought if I break out of something, it breaks the whole thing, but no, it only breaks the first loop. So if you want to break 2 times, just break it here too. Boom. But obviously none of these was necessary. So yeah, just wanted to demonstrate the use of important things to learn here are break, how to print stuff in a line, how to break a line, modulus, and size of a vector. Hey. Amazing stuff. Now I'm going to move on to a very kind of simple code I have, but extremely key thing to learn in MATLAB. And that's also, again, very confusing. And that is the use of functions. Hopefully I get to teach you something here, even for the people who know something about MATLAB. So in MATLAB, as far as I'm aware of, there are 3 kind of main ways you can use functions. And I'll go through them one by one. Does anyone know what the 3 ways are? I'll put that out there. There are other ways, but 3 main ways. The rest are kind of very strange ways of functions. Has anyone heard of anonymous functions? Maybe I'll say it there. If you heard of it, just say yes. Anonymous or inline, sometimes is the other word for it. I'm guessing no. So yeah, I'll start. Clear. Yep, so as I was saying, there are 3 major ways that I know of that you can do functions. And the first one is the anonymous, sometimes referred to as inline functions. I'll show what it is, and then I'll explain when to use it. So example, super duper easy example. You don't even need a function for this, but just for the sake of it, I want to find the area of a cylinder given in the radius and the height. Okay, so I type, and you'll notice why this is important. I type area of cylinder. Did I spell cylinder? Yeah. And I say equal. And here's the key character to remember, the @ parentheses, and the stuff that are your inputs. So my inputs are radius and height. And you just type out your equation. So pi dot r squared dot h. So now if I run this code, see what happens. Nothing gets printed because it's just a function. But if you look at here, it's now an object. It's no longer variable, it's an object, and it says it's a function. So if I open it here, it says, oh, it's a function of R and H, and it's a function handle. Now, why is this super useful? At the very top of your code, wherever you like it, you can define these. Anonymous functions are super useful to define anywhere you like. As long as the equation is simple, you can see my equation is a one-line equation. So use this, I usually use these for unit conversions. So let's say you have, I don't know, you have like grams that you want to convert to, what are the units are? Pounds, let's say. Rather than doing it inside each time, multiply by constant, just have like an anonymous function like this and just say grams to pounds, for example. So these are very, very simplistic stuff. You can have many inputs as you like, but it has to be one line. It can't do multiple calculations and all that stuff. And the important thing is it can only return one value. As you can see, the return is just this calculation. It will never return two values to you, right? So use this if you ever want to return one value. Super duper simple. And the way to use it is anywhere in your code. It doesn't have to be right after. Anywhere in your code, you can just say, well, let me see. Let's say I define my height equals to 1, radius equals to 2. And I want to find area 1. So area 1 equals to area of cylinder. You call it as if you were to call any other function with your same inputs. So R and H. And if I run this right now, you can see it just calculates the area. Now you don't need to have R and H here. You can directly put, I don't know, 1 and 2. That'll work. But I suggest don't do that. And always stuff have here as not constants. Again, try as much as you can to write everything in terms of variables. So that's how you would write that. So that's quite useful. Now, what's the other way I can use a function? Go all the way here. These are called inline functions, or in-file functions, sorry, in-file functions, and they have to be at the end. So other languages, C++, Java, you can define functions at the top of your code. MATLAB has to be at the bottom. And so the way you do it is it's no longer like this. You literally have to say the word function. The thing it outputs, which in my case is area, equals the name of the function you want, so area of cylinder 2, and its inputs. Then you do your calculation here, which for me was this. So area equals to this. Now, as you can see, this is much longer than that, which is why anonymous functions are super useful to use for simple stuff. However, here I can do multiple things, right? I can have a function that doesn't output anything and just says, say hi, doesn't input anything, and all it does is and I can just call this function here. Say, I didn't close something. Oh yeah, there you go. So I didn't close the text. So you can see I can do other things with these functions. So I could have a bunch of text here that could print something, and I can have this anywhere I like. So that's quite nice. In programming languages, these are called void functions because they don't have any output. But back to our inline function, in-file function. Here, the way I would call this is like any other function. I'll put this here. Let me put these here. So I would just say area 2 is equal to, it would be the exact same as above. And you can see area 1 and area 2 are the exact same here. The advantage of these, again, are you can have multiple outputs, and the way you would do multiple outputs are like this. So you would put them here. So area and let's say parameter. I don't know how you spell parameter. Parameter is equal to, what is it? So it's 8. So it's 2 times pi times r times h. And the way you call this now is you have to have both. So you have to have a2, and I'm just going to call it p. So now this has 2 outputs, and I have 2 outputs here. As you can see, the p and the area. For somehow I made them be the same. Oh yeah, because r is equal to 2. That's nice. Okay, let's change to r. So it's different. So as you can see, the advantage of this over this one is you can have multiple outputs. That's basically it. And you can have other stuff in it too. So you can have the say hi in it too. And so when you run it, it says hi. I'd highly suggest using this 99% of the time and only leave this to simple unit conversions or like simple formulas. So there's that. Now, the third type of functions, where your function is in another file, right? So here, my function was at the end of my file. Oh, actually, let me take one other note. One important thing that I was saying is these have to be at the end of your file. If you have something here, if I'm not wrong, it gives you an error. There you go. Yeah. See, function definitions in the script must appear at the end of the file. So it does not run anything after this. So make sure you have that in mind. Functions at the end. So yeah, functions in other files, right? When you deal with massive projects, you don't want to have one file that has 1,000 lines of code, right? These would be kind of annoying to have hundreds of functions at the end of your file. It is much nicer to be able to break this into a completely separate file. And this is where like MATLAB might become confusing for people, but so pay attention here. It's quite useful. I do this pretty much every single time I code in MATLAB, having my functions in different files. And so I'll show you exactly how to do this. So the way you can do it is go to your current folder and just right click, new. You can do a function, but then you can do a script. When you click on a function, I'll call it super duper important moment. You have to name the file the same name as your function, right? So I have to call it area cylinder. I think I'm calling them 3, right? Boom, 3. And so now if you click on this, it automatically has like a template for you. Here's your outputs, your inputs, the name. It makes it automatically for you with the same name. This name has to match your file name. So keep that in mind. If I don't match it here, so let's say I do it 6, it should give me an error. See? Function name must be the same. So keep that in mind. So now let's go and write this as well. So again, I have an R. I'm just going to copy paste because I'm not going to I'm going to write this. So boom. I'm just going to change this to 3. Cool. Now, the way you would call this is exactly the same as everything else. So you literally can call it right here. So area 3. 3. So area cylinder 3, and boom, called it all good. Here are my variables. So as you can see, area 3 matches here. So it's basically like taking this and putting it into another file. It's really, really nice to be able to break stuff up. Now, the reason sometimes this might get confusing is when you break the function up into another thing, as you can see, my main code, which is called function 6, is in the same folder as my function. But let's say you download a code from, I don't know, online, or your prof gives you a code and it's not in the same folder, right? The way you can run that function is either drag it and put it into your same folder, or add it to path. I'm going to show you how to do that now. So again, so what if the function's not in the same directory? And directory is the same as folder. Same folder. So as you can see, I have this folder here, which is right now gray, right? It means it's not in my directory. I've pre-made this function, area cylinder 4. If you look at it, it's exactly same as here. So I'm just going to copy paste this back. Right. Again, the name has to match. Now let's see what happens if I try to run that. If I try to run this, it cannot find that function. It's not in the, it's not in the current folder. But MATLAB, however, is smart enough to tell you, hey, but it exists in this folder. What would you like to do? Right? The simplest way you can do this, usually, I'll show you how to do it. At the top of your code, right? You know how in other programming language you'd say like, oh, import NumPy or import Java util or include iOS stream. At the top of their codes, people like imports packages, right? You could do the exact same thing with MATLAB. The way you do it is you say add path, gen path. So you generate the path of that folder. So I know my functions in this folder called functions, right? So you do functions. You have to have it in a text. So what this does is dot says, oh, wherever the file is, just appends this to it. So this line of code generates a path exactly here. It takes a function and just makes this entire folder. It makes this entire thing. And add path adds that folder. So let's say if I just run this right now, just for you to see what happens. If I press run, you can see now this no longer is gray. It actually becomes colorful, which means it's in my path. So if I run my code now, I no longer get an error. So you can see my workspace, area 4, I have something here, I have a value. So this is super duper useful to know how to add folders, right? And highly, highly suggest put these, even though I'm using this all the way down here, put it at the top of your code, just so the grader, the TA, whatever, they know what path you're using. Because as soon as they download your homework, but they put it in a different folder, this code no longer works. However, the TAs know that they can just change this and it will work, right? So put it at the top of your code. And maybe make a comment, oh, change to directory. Right. Download the directory. So highly suggest you do this. And that'll be it for that. Any questions on here? These are the main, well, 3 ways, but I guess these 2 count as one that you can do functions. Any questions here? I think this is an area I can spend time on if it wasn't clear. So there's only one function code. Exactly. Yep. Because since the name of this has to match the name of the file, only one function goes to each file, right? So you might end up with multiple files. I'll show you how here's for example, an assignment that I have. Hopefully you can see, for a course, this is my MATLAB drive that I was telling you about. I can show you how to do it after. So let's say for a course, this is how I code usually. So if I have a task, let's say task 3, I have my main file here. And I put all my functions in different things. So let's say I have a function here. I have all my functions here. Each of these are individual functions. Since this was like a somewhat of a big project, this is how I do it. And in my main file, I call this. You see generate path to that, generate path to that, generate path to that, and I just call my functions. So that makes my main code be super easy and clean. This is the purpose. That's my name. These are the stuff. My constants, variables. Your code will be super duper clean, and it's very easy to debug what is where. So that's why I highly suggest it. Yeah, no worries. These are all just ways for you to see. So for in-file functions, you can have multiple functions at the end. Exactly, right? So you can have as many functions here as you like. You can have however many you like. I think I have let's see if I can show you an example. MATLAB drive, useful. So here's a code that I wrote. You can see all these functions I have. And I usually just say, oh, plotter functions, categorize them just so you know what's what. You can have as many as you like, exactly. So yeah. Yeah, this was a cool function I wrote a while ago. I'll play that at the end. It's like a BuzzFeed quiz. Ask you a bunch of locations, and then based on your responses, it picks something for you. Quite cool. So any other questions? Where was I? I was here. One thing I don't think I've talked about, because I don't have a super easy example. All these functions, as you can see in my workspace here, the difference between, so when I run this code, right? The difference between this anonymous function and all of these is, if I look at my workspace, that's the only function that's here. These, this, that, the other files don't appear, right? The reason why that's super important is I can use this function as a variable, right? MATLAB sometimes has you solvers, so I think, let's say, I don't know, it won't make sense here, but like lin solver, I can pass this function as a variable to it. So I can pass this as a function to it. Whereas with these other ones, I can't do that because they're not a variable. So that's why this is kind of sometimes useful. So if you were to ever solve something like, if you ever wanted to solve like a linear solve or whatever, it will ask you, hey, could you pass your function as an anonymous function, right? So like the way you would do that is, let's say you're required to do that. You can have your function here, and let's say you don't want to rewrite it. All we can do is just say area anon, let's say, or whatever name you want to have it, be a function of R and H, and literally have it call this. Boom, that's a totally valid function call. As you can see, now you have a function handle. So if you don't want to rewrite this in this format, you can just do this. It's a super duper useful tip to know. Cool. Now, if there are no more questions, I'll move on to kind of like the last part I've prepared, which is how to plot stuff. MATLAB is probably most customizable part. I think I've sunk maybe hundreds, I want to say, hours on plotting stuff, just because there's so many things you can tweak. It's incredible. So I'll move on to plotting. Do I have it here? Functions. Nope, I guess I'll create one. So script, plotting, and that's 7. Cool. And I don't know if you've been paying attention to what I have on the on this side. Sorry. The details. If I click on any file, let's say you don't want to actually open the file, right? I don't have the file open here. So assume I don't have this open here. So I can just click on this. And on the bottom, it tells me all the functions and all the stuff I have. So that's quite nice. Keep that in mind. You can, when you click on it, it brings you to that. So if you have a very long file, like I don't know, I've had thousands of long, like 1,000 line file, that you can just click on the function you like, and it brings you to that. You can see it highlights it and stuff. It's quite nice. Yeah, those are just side tips. So plotting, how to plot in MATLAB. Hopefully, I'll try to explain this as best as I can. Let's start with an easy example of plotting one line and one variable, right? Oh, oops. So I have an x1. Oh, 1 second. I gotta. So I have an x1. Starts from 0, 0.1, all the way to 2 pi. So if you remember all the way from how I define matrices, this just defines a vector. If I run it here, of x1, starting from 0, moving all the way to 2 pi. And y1 is equal to sine of x. As you see, I don't need to loop through this individually, take sine of each thing. MATLAB functions such as sine, e to the power of something, cosine, they all are built in except vectors. So if I immediately run this, you can see, oh, x1. So x1, it immediately just calculates everything. So no need for you to run through everything. Now the simple, level 1 way of plotting stuff is just saying plot x1, x coordinates and y coordinates, and you're done with it, right? And you get a plot. Now this plot has no title, has no legends, no grid. I forgot what it's called. Yeah, no legend, no labels, nothing. 99% of the time, if you submit something like this, they'll probably give you 0, right? So the way you do it is, you can keep this. Highly suggest you define a figure, right? So that way you can alter that figure. So the way you define a figure, just say your figure, name, and give it a name. So the name you're going to give it, the name you're going to give it is, I'm going to say plot of sine of x. Okay. And so now what you've done is, that if I don't have this here, see what happens? It's just figure 1, right? But if I uncomment this, at the top it says figure 1, plot of sine of x. So 1 step there. Now I want to make that graph look a bit neater. The way you can do it is say box on, draws a box around your graph, and grid on. Unfortunately, these are stuff you just have to memorize. The way I've done it is I have basically a lot of ways to plot stuff in a file. And every time for an assignment, I want to plot something, I look through that file. I'm like, oh, what do I use now? Right? So if I run this, now you can see I have a box around it and I have grids. So let's see what else we can do. If you want to add a title, literally just say title and your stuff. So sine of x versus x. And if you want to add x label, y label, x label, I'm just going to say it's x. Y label, I'm just going to say it's y. So already looking a bit better. And lastly, you want to add a legend. They're very strict about this. So legend y equals to sine of x. And boom. There you go. Here you have this. I highly suggest y'all look up, so if I come here, this is anonymous functions, by the way. If you want to Google all these, MATLAB, great support. So MATLAB plot. It has so many examples and so many useful resources here. I highly suggest if you ever want to go through, look at it. But the main parts you want to look at always are these. So these are the different types of ways you can draw lines. These are different types of ways you can draw points. The colors you can change. These don't actually matter that much. Yeah. So just to give you an example, let's say I want to dash the line that each point is a circle and I want it to be blue. The way I'll do it is I'll go here in the plot, right here, comma. So I want the dashed line. I want a circle to be each point and I want it to be blue. and you can just run it, and this is what you get. So that's why MATLAB plotting is so insanely nice, because by changing one line, you can just change your code so much, and it's super nice. One other thing, just so you're aware that you can do, is let's say I do this, but let me do the other way. Let's see, how do I, just for the sake of it, I want to show you one thing. So I have my sign up. If I run this, you can see how right now my plot goes into my legend, right? Unfortunately, MATLAB is not smart enough to detect, oh, this is covering your stuff. The way you can do it is, where is my, okay, here it is. So you can do legend location. I want to show you here. So if you go to legends, here you have all this different types of locations you can have. So, however, what I would suggest is using these ones. So best. So you can just say legend. I'll do it here. Location. And boom, it realizes, oh, now I'll just move it down, so it's no longer conflicting with it. But this might look unprofessional, so that's why I like to do it manually based on these. So I can say, oh, east, west, all that stuff. So just know that you can do this. You don't have to memorize how to do it, just know it's possible to do. Okay, is that so far clear? Does that make sense? Hopefully. And one other cool thing, all of these, if you've ever used LaTeX, MATLAB accepts LaTeX notation for all of these. What that means is you can do stuff like, oh, if you use underscore like 2, it automatically turns it into a subscript. So keep that in mind too. I'll carry on to show you another thing. Actually, I'll do this. I'll do it here. Another way you can use show legends is here. I define a legend here, but you can also put it here. You can say display name and put the legend name here. So y equals sign of x. And here you just say show. Some people prefer to type it here, just so that that's clear which legend belongs to which graph. It'll be up to your preference. Just don't forget the legend show thing. If you don't have this, so if I comment this out, it doesn't show it. Unfortunately, it's not that smart. So keep that in mind. You have to type in show. Cool. I'll continue on to how to plot multiple things. Because let's say I have a cosine. So y2 is equal to cosine of x1. And if I just try to plot the same thing, so let's try to plot it. So name plot sine of x and cosine of x. So plot this. Y2. Sine of x versus this. Now, if, let's say I try to run this code, right? You can see it does not plot sine of x. The way you combat this is, I'll change this to red just so we can see the colors. The way you make it be short to do both is by the keyword hold on. Absolutely super duper important to memorize this. Hold on, And make sure you remember to say hold off. So now if I run this code, now you can see both plots right here. And I changed, as you can see, I changed this to red. So that's why my cosine is red and my sine is blue. Does that make sense, everyone? Hopefully. Yeah, and lastly, I wanted to kind of tiptoe into 3D plots. There are tons of 3D plots. So it really depends on the application you're trying to use, but I just want to show what it looks like. So here's a 3D plot of a surface. And the way for 3D plots you actually require a grid, right? And for that, you have to use a function called mesh grid. Now I'm going to use exactly the same thing. So I'm going to use exactly the same thing here. And I'll show you what that function does. For now, I don't want to plot these just so it doesn't get confusing. So if I look at X, you can see now they're matrix. Before X was a vector, even though I'm using the same thing, before it was a vector for 1/66, now it's a matrix. All that's doing is here, look, it's literally creating the same thing 63 times. Just because you require it to be a matrix for 3D. And so the way you plot this is you just say, well, surface X, Y, and let's say I want to plot sine of X plus cosine of Y. And this is how like a 3D plot will look like in MATLAB. And like, obviously you can turn it around and stuff like that, but hey, that's it. And the commands will be exactly the same. You can use the same, figure, hold on, all that stuff. So it'll be exactly the same, but it just looks cooler. I don't know. And that'll be it. Now, one last thing I want to cover. Let's see which code is thick. Is how to print your code. So let's say you've done the assignment, all that, and now they're asking you to submit your code, right? How would you do it? I'll do this. I'm trying to change these to chapters. Cool. So now the reason I changed it to this just a second. So you go to all the top. You don't have to take screenshots. I mean, you can take screenshots, but it'll look ugly. You can copy paste, but it'll look ugly. The best, most incredible way I realized way too late again, is go all the way to publish. You see this publish thing, click on the bottom, edit publishing options. Here you have all these different types of ways you can publish. I always like to use PDF, your choice, and you just click publish, right? Let it do this. Oh, that is my, it brought me to a different screen. Okay, here we go, back. So here, it automatically generates a PDF for you with the table of contents and I don't know, the legends, whatever, and everything's in color and all that stuff. And it's pretty nice. I think it looks pretty professional and really nice. I just close current tab. And like you could publish in different things. You can publish in HTML, which kind of looks kind of cool. You have this whole, looks like a website type of thing, and you can click on stuff and it brings you there. You can see, I don't know, I think it looks pretty nice. And all of these would be saved. MATLAB automatically creates a folder called HTML here, and in it is your PDF. So if you don't find your PDF, it's there, just so you know. So I think there's that. And yeah, with that, that's everything I've prepared. I didn't prepare a project because I looked at the code and it didn't look super clear to me. So what I thought I'd do is I can answer questions, and then if you don't have any questions, I can go through a bunch of the cool MATLAB code I've written and kind of like show you the amazing stuff you can do in MATLAB, just to motivate you about why MATLAB is amazing. I learned MATLAB, I think, in my 3rd year, And since then, I've used it for every single course, even if they didn't require it. Like I even use MATLAB for an anthropology course. There's so many cool stuff you can do in MATLAB, and it makes your life super duper easy. So highly suggest. Probably the best trick that you can use in MATLAB. This will be I can do another session for higher level stuff. Is using MATLAB symbolic tool. So you call sims x and y. And now x is a variable, right? So what you can do is you can define like you can define an equation like c is equal to x squared plus x. And if I run this code, where is my thing? So you can see c is now an equation. And you can do very funny stuff like differentiate c, and we give you the answer. So if you ever had like a web work question and stuff, you can define your variable here, define an equation, and in MATLAB differentiate and integrate stuff. Like I think that's super useful and helpful in so many different things. Like homeworks, I don't have to do by hand anymore. I just put it in MATLAB and just write differentiate, and it does that. So I think that's a very powerful tool. If y'all are interested around, I can show you cool projects or answer your questions. I guess I'll first wait till if someone has a question, and if not, I'll show you cool stuff. So this will be purely for interest. You don't have to. I don't think you'll learn much. So
I actually have a question. So I know in Python you can have lists with like different types in them, and like Java you can't. Is there a way to do lists with different types in MATLAB?
No, not that I'm aware of, unfortunately. Right. So by different types, you mean like have an array of like numbers and strings and all that, right?
Yeah.
Yeah, no, unfortunately there's not. However, you can define your own objects in MATLAB, right? And that way you can, but it's not really a straightforward, like easy way. So for example, do you have like an example in mind of like how would you benefit from that?
I don't remember at the moment. I remember last semester when I was using MATLAB for an assignment being like, oh, it would be useful if I could have different types here, but I don't remember exactly what.
Yeah, so the way you do it is in your current folder. See, if you right click new, you have this place called a class, right? So in class, I don't know, I'll just say Sep. In class, you can define, it's exactly, if you've ever done any other programming language, it's exactly like C++, we can define a class, right? So class Sep can have a height, which is an integer, a name, which is a string, I don't know, whatever. So it could have different types. These don't have to exist, right? These don't have to exist. And so let's say in your code, you can define, Sep. So the way you'd use Sep is like Sep would be an object, and you give it a name. So X, let's say, equals, you have to define the height, and you have to define the name, Sep. So that way you can have multiple stuff in a single object. And so from here now on, if you try to use X, you can actually carry these stuff with it. So that's quite useful.
Do you have to define what type the things are in the class itself?
No, you just have to make sure it's in the same order as here. The way you do it, let's say if you don't define it like that, I think you have to define it. So Sep X, right? And then you say X dot height equals to like 12, and X dot name is equal to I don't know, Sep. So that's how you.
The first instance of the class that you create will sort of assign what type it is.
Yep, exactly. Yes, I believe that's how it worked. Yeah. So that's quite nice. Do Google objects, but I don't quite have it on top of my memory, the syntax, but that's one way you can actually do it. I've not used it that much. I think I've used it like twice maybe in my life, but it's cool to know that you can do this. But the important part is this has to be its own separate file. I've tried so long to create one within the, so I try to copy paste it at the end, because in other languages you can do that. Have your objects at the top or at the end, but you can't do that in MATLAB, unfortunately.
Thank you.
Hopefully that answered your question. any other, I've done some crime stuff in MATLAB. Like you can do so many dumb things. Like look at this. Like this is one of the things that I would count as being criminal in any other language. Look at this. So I'd say, I don't know, n is equal to like a function. So like a this is a string, right? So x is equal to 4, right? So if I just run this code, my n is literally a string of n equals to 4, right? But the dumb thing that you can do is you can say, well, evaluate. Be nice if I knew how to spell. Yeah, evaluate n. I think
There's
that's
an A before the U, or after the U,
see,
right after the U.
You know, it sucks to suck. Let me see. I forgot how to. Oh, eval. Sorry, eval. Not evaluate. And see, when I evaluate n, it actually prints x equals to 4. So this way you can have your code in variables and you can pass it along. So let's say you have a code in one function that you actually don't want to be in that function, you pass it to another function and you evaluate it in somewhere else. I've done some messy stuff with this. Just know that's also an available, like I don't know any other programming language that has this feature that allows you to evaluate a string. So know this exists. I want to see if I have a place where I use this. Yeah, it's not my proudest moment. But I was going to show you some cool stuff. So I said I'll show you the MATLAB drive. It's going to take some time for it to load. There's a bunch of stuff. Yeah, so these basically are all the stuff I have online. So if I go to useful, you can see I have a bunch of cool stuff here. Let's see what I would show. Yeah, the coolest one I had here was the birthday wish one I made for people. I send this to my friends basically all the time. It's basically taking their name, their date of birth, all that. You can see I'm using switch statements. I guess I'll show you where I'm using it. So input is a function that types something and waits for the user to type something in the box. And using the switch, I'm able to determine what they typed in. Don't worry about all the stuff. I'll run it just so you can see what happens. So yeah, first name, Sep, family name, I don't know, Sep. Maybe I should have my full name. Date of birth. It's great that I'm publicly showing my date of birth. The cool thing that it does is like it makes this happy birthday. You've been awake. You've been alive for this many seconds, and it makes you a cake. I bet no one ever in their right mind thought you can make a cake in MATLAB, and you can blow up the candles and light them up, and you can blow it off. I just thought it was a pretty dumb fun thing to do in MATLAB. I thought it was pretty cool. The other dumb things I did, as a word cloud generator. So I wrote this for my anthropology course because I wanted to create like the prof would give voice recordings, and I wanted to turn those voice recordings into text into a word cloud, basically saying how many times each thing has been used. And so I made this code to go through basically all the text. I don't know if I can run it now. Hopefully we'll see. So I gave it the folder location. As you can see, I gave the full path of where to look for. I wanted the top keywords, as I said, store everything as variables. Like I don't want to ever use something 10 here, for example. I don't know if it will throw a run. We'll see. Oh, it does. Okay. Does it print anything? Oh, there. Oh, wow. Okay. That's kind of nice. So that this went through my entire course, the entire transcript of my course, because it was online, it was on Zoom, and counted each word, and then just says conservation apparently, and people are the top, which makes sense. Governance. I don't know. I emailed it to the prof, and they absolutely love this. It was pretty freaking cool. I don't know, just dumb things like this that you can do in MATLAB. or for those of you who are in mech, I think everyone here is probably in bio, but if you're in mech, I did one of my final exams in MATLAB. Here are the inline functions that I was telling you about, because they're all just like basic stuff, like calculating temperature and stuff. But this was like a function I used. So I just submitted a MATLAB code for my final. No work showing whatever. The prof would loved it too. Yeah, so that was pretty cool, I thought. One other cool thing I didn't talk about, I should have, global variables, right? So in this function, if I use, so I defined a function, I defined global variables, gamma 1, gamma, all these stuff, and I assigned them a value here, right? If I don't want to pass these functions every single time, I declare them a global. Now in this function, this value of gamma would be the value here. So kind of cap that in the back of your mind that you can use global variables, although every single person that ever codes tells you not to use these because it messes things up quite a bit. But for small projects, it's not the worst idea in the world. So yeah, have that there too. I don't know if I could show you other cool stuff. I made has anyone ever played Beer Die here? I made a Beer Die game. I don't know if I have it here. Oh, here's a pi estimator question. So if you have a square and you randomly generate points inside the square, if I have it, I can run it here. Right? If I randomly generate points inside the square and I calculate the number of points that land in the circle, I can estimate the value of pi to a very, very good accuracy. You can see I found it as 3.1411. How did you learn most of your MATLAB skills? Honestly, a lot of curiosity and a lot of Googling. I didn't take any courses, but MATLAB documentation is so insanely well written. Every single programming language, I can code in C++, C, Java, and OCaml. They've all been written by computer science people, so their documentation is super ugly, just purely raw, whatever. But I've shown you a bunch of documentation for MATLAB stuff, and it's just all looking so nice. You can copy the code, there's illustrations. It links you to other stuff that might be useful. It is so, you can learn so much just by doing these random stuff yourself. So I highly suggest whenever you're curious, just say, oh, can I do it in MATLAB, and try to do it. Your life becomes so much easier. I'll show you two more things just for the sake of it. Here's some, I had a course last semester, yeah. It's called Theory of Chaos, so nonlinear dynamic and chaos. It basically showed you like in randomness, you can find like cool stuff. So here is a code that just randomly generates a number and multiplies it by a specific matrix. And so I'm going to do it a million times, like 100,000 times. And turns out the shape you get is exactly like a leaf. And if you go on Wikipedia and look up Burns, I don't know how to pronounce it, Barnsley fern, there are different matrices and they produce different types of leaves. I thought that was pretty cool. So that showed us that, the patterns and leaves are not actually random. They're chaotic, but they're not random. They all follow like a matrix formula. So that was pretty freaking cool. There's another one. It's called Chaos Game with a Triangle. So the way it works is, can I annotate? Let's say you draw a triangle, right? You give this top point values 1 and 2. You give this 3 and 4. You give this 5 and 6. And now let's say you put your pen down somewhere in the triangle, let's say here, and you draw a point, right? Then you roll a dice. Let's say your dice lands at 3, right? So lands at 3. So you pick this point. You put another point in between the middle point of these two. So between this and this, you put a point. So you draw a point. You roll the dice again. Let's say it's a 5. So you pick the middle points of these. And you keep on going. Now the question is, if I do this like 100,000 times, what would happen, right? So let's see here. So the length of the triangle, I'm just going to choose 1. Starting point, I don't know, somewhere. And I'm going to do it 100,000 times. This is the pattern we get. So the blue dots is everywhere the point landed. And it creates a fractal. So even though I'm rolling a dice and it looks absolutely random and completely chaotic, you actually get a very clean repeating pattern that goes on forever. And I thought that was super freaking interesting. And the mathematical reason why you never land in the middle is because to be able to land in the middle, you have to have the middle point of this and somewhere outside the triangle. So you never land here. Since you never land here, you never land between the middle point, you never land between the middle point, you never land between the middle point, and so on. So that's pretty freaking cool. And just you can do so many of these like cool dumb things in MATLAB, which I thought were super nice. I don't know if I have the I've even done I've done presentations in MATLAB. That was the other. I don't know if I can show this. Yeah, I did a presentation for Frosh. I was quoting Frosh, and it was how to do a theme release. I don't know if this is going to be appropriate, but we'll see. And so the way I did the presentation is I took screenshots of the PowerPoints and I imported them as plots. So every time I literally plot the screenshot. So it's pretending like it's hacking into the files and stuff. It's just random shit. I'll let you read. I put passwords for the slides. So the first question is E equals pi equals square root of G. The engineering answer is equal to 3. And so it'll load the first slide of the PowerPoint. And I'll move on. How much is a grilled cheese at Blues Pub? $1. I don't know if I have the dollar sign there. There you go. I'll give another. So I don't know. I thought it was pretty funny that you can do a presentation in MATLAB. So I did that too. One thing I forgot to mention that's kind of actually important. If your code runs into an infinite loop, let's say, or if you're bored, I don't want to continue showing you all the slides. If you type Control C, it completely shuts down the program, right? So that way you can get out and do other stuff. So that's one interesting thing. Workshop. Okay. I really wanted to show you the 3-man game, but I don't think I have it here. So unfortunately, yeah, I wrote my thesis. Much of my thesis was in MATLAB. All these courses that you can see, I've used all MATLAB for these. But yeah, that'll be it. I don't know how much more do you want me to show. But yeah. I think we can stop it here. I've been rambling on other stuff. What was the name of the course again? The chaos one? Oh, Math 326, I think. Let me look at. Highly suggest. Probably the coolest course I've taken in McGill. Not super hard. The prof is a prof from MIT. He's actually teaching in McGill now. He's teaching the same course. It's an insanely cool course. Oh yeah, actually, I'll show you one other thing. Here's the famous Mandelbrot set. If you go look up on YouTube, Mandelbrot set, it's pretty insanely cool. It might take a while to generate because it's a very thick prof. Yes, Emma, I do have a minor in math. Here you go. This is one of those repeating fractals that forever goes on and on and on. And there's hundreds of YouTube videos zooming into this forever. So if you want something to trip on, highly suggest this. Go ahead. Yeah, that would be it. If anyone else has, well, I lost my voice. If anyone else has any questions, I will be here. As I try to find that game. Maybe it's Frosh. Oh, okay. Does anyone know what the game 3-man is or not? I don't know if it's well known. It was an E-Week if you ever went to E-Week. Basic was a dice game. You roll a dice and based on the outcome, someone does some activity. So that's why I use the cases, because you can only have 6 cases in a dice and all the if statements on what to do. And as you can see, the functions at the end, quite useful. I put a function at the end just to print something because I knew I was going to print it multiple times. And yeah, you can really see how I like break down my code into multiple functions so that my main code is just pretty simple. And yeah, that'll be it. I will end it here and have a great night if you don't have any more questions.
Thank you so much for hosting.
Yeah, sorry, I went completely off rail at the end. I'm like just showing random
I
stuff.
enjoyed it. I want to like put a presentation in my MATLAB assignment or something.
Yeah, hit me up. I can share the cool codes if you want. On Friday, I'll put them all together in one file with the recording of this. Y'all can share it. It's quite nice. Kind of cool.
That would be great. Yeah.
Yeah. Cool. No worries.
All right, I'm going to stop the recording.